Hello, everybody. I will continue with this program, and I want to talk about polymorphism. Polymorphism simply means many forms. That means one reference variable can point to different subclasses, different objects at different times. So now if you look at this is an animal reference, and it's pointing to a reptile object. This is a bird reference, and it's pointing to a bird object. So when you compile the code, okay, let's look at this. This is, oh, by the way, I'm adding each object to the animal array list. So now each object is actually an animal reference variable because I added them into the animals. The name is animals, but the type is animal. So now they become animal, and bird becomes animal, snake becomes animal because they are added to this array list. Okay, so here I am printing each one out. And by the way, you remember this is the same as toString. But if you are using this object in a display statement, output statement, you do not have to specifically call the toString method. toString method, right? It's automatically called. Or when you here you have to call because otherwise you cannot reference it. Okay, so or when you concatenate an object with a string, then you do not have to call the toString method specifically. So I'm going to, it's called automatically or implicitly. So I'm going to delete that. I want to discuss this move, A, which is the variable, just to go through the animal array list. So when you do this at compile time, because this is an animal reference, okay, it's animal reference, at compile time, the system will look at the reference type for that method, which means it will go to animal class to look for the move method. Okay, so for example, if I comment this out, let's see. If I comment it out, you can see this will not compile, even though the first one is snake, it's an animal. Oh, this it's a reptile. The second one is a bird. They both have the move method. They both have it. Oh, I don't remember when I did this. I think last time. So even though they have the move, and now this doesn't compile, so it's a chain reaction, really. So what that means is when you do this, when you call the method, it goes to the reference type, and the reference type is animal, not reptile, not bird, but animal, because I added them to this array list. So it looks for that method in the move in the animal class, and it doesn't have, so it will not compile. But at runtime, it will actually look at what A is. If A references a reptile, then it goes to the reptile class to execute that method. If it is a bird, it goes to the bird class to execute that method. That's called dynamic binding. And it's also, of course, polymorphism. That means this A, this reference variable here, I just call it A. You can say animal, you can say object, anything. It's animal type, but it points to different compatible objects. And the bird, cat, dog, reptile, they are all compatible with animal because they are subclasses of animal. So that's one thing. That's the polymorphism part. That's the dynamic binding. Let me repeat that. At compile time, it looks for the method in the reference type. That's the reference type. okay, reference type. At runtime, it uses the method body of the object type. This is the object type. So at runtime, it uses the method body in that class. At compile time, it looks for the method in the reference type. Okay, so when you do your program, sometimes it doesn't compile. Think about that. So this now will print out and we'll call the move and everything. And here I just want to show you that you can create an array instead of an array list. You can do that too. And here I'm creating a very generic animal. Say it's not warm-blooded, right? It's false. So here it will create an animal that's cold-blooded. And I'm having 3 objects there. And here, this is another example of creating an animal array. And here, these, as you know, are called anonymous objects because they don't have a name. Unlike these, you know, this object name reference variable is snake, and this is bird. These don't have a name because you created them and you want to put them into the array. So there is no need for a name itself because you can reference them using the subscript. So that is just to show you, you can do that too. And here, this is printing out after adding, okay, this is printing out the array for this part, right? And you can, again, you can see this a.move. The first one will call the move in the animal class. The second one in the array will call the move in the cat class. The third one will call the move in the dog class. And speak is the same. So I just want to show you that. And now I'm adding those array elements to this array list. So now I will print out everything. Let me just delete those so that we don't have too much. Okay, everybody, just so that you know, not sure if you know, but you can just select that, press Control-Shift-C to comment it out. And then to get rid of the comments, Control-Shift-C to get it back. The good thing about this is it keeps the formatting. If you use the source add block comment, it messes up your formatting. Okay, so 2 animals, 2 objects, and 3, I added them. Now let's print it out. And you can see that's the first one, that's the snake, bird, the generic animal, cold-blooded, and the cat, the dog. Those are the objects in the array, right? Okay. So the next thing I want to talk about is, again, it has something to do with polymorphism. I want to show you Control-Shift-C. I want to show you, okay, let me comment this one out first. So now let's look at this code is to print it out. That's to add to the array list, right? You understand that. So you can use this, this for loop header also, just the traditional for loop header. And animals is an array list, so it has a size method. You use that. Okay, I'm using animals.getI.sniff. The reason for that is in the dog class, I added a method called sniff. Okay, this method is not in the animal class, right? It's just in the dog class. And it returns a string, which is I sniff at everything. And in cat, I also added a method. This one returns a void. I want to show you the difference of how to use these different return type methods. So this one returns void, and it simply prints out this string, okay? Bird does not have that method. Reptile does not have a new method. I should not have commented this out. I think last time, in the last video, I did this. Okay. So, so now I added those two methods for dog and cat. They are different and they are not in the animal class. And dog has this dog return string, and cat doesn't return a string but void, and it prints it out. So now in this, I will just do this for loop, and for each element in the array, I'm calling sniff, right? And this obviously does not compile. First of all, let me tell you why I'm doing this. I'm doing system.out.println for the sniff method because sniff returns a string. So I get that returned string and I'm printing it out. For the stare and hide method in the cat class, I'm not returning anything. It's void. I'm just printing it out. So when it's void, you just call it independently. So here, that's why I'm just calling it. But this does not compile. Why? Because sniff, okay, first of all, remember, what reference type is this? The reference type is animal. So when you compile, the system will go to animal, the class, to find the sniff method. And in animal, there is no sniff. That's why it doesn't compile. And in animal, there is no stare and hide. That's why it does not compile. So that further illustrates what I said. That means at compile time, it looks at the animal, it looks at the reference type, not the object type. So in order for that to compile, I'm going to comment this out, Control-Shift-C, and let me, instead of typing, that takes time, I just typed them already. So now, this is how we do it. Okay, we can do the move, right? We can do animal.move, get I.move, because everybody has move, and also because animal has that method. So we can call it because it has move here. And we can also call the speak because animal has the speak. Get I.speak, right? These two methods are in the animal class. That's why it compiles. And here, so you know that sniff and stare and hide are not in the animal class. So we need to test and see what actual object it is using the instanceof operator. So animals.getI, get the object, test if it's an instance of dog. Okay, and if it is, am I still recording? If it is an instance of dog, then we call the sniff method. Else, if it is a cat instance, we call the stare and hide method. So this is how you call this. But then look at this. If I do not, you say, okay, this object, it is a dog, right? Because I already tested, it meets this condition, so it executes this statement, but still it does not compile. Why? Do you remember why? It says the method sniff is undefined for the type animal. And remember, this is an animal reference, even though it's an object of dog, but the reference type is an animal. And at compile time, it looks for that sniff method in the reference type, which is animal, and it cannot find it. So it doesn't let you sniff. What you do is, you know it's a dog object, so you have to convert it, cast it into a dog for it to compile. So now you remember, you put, that's the type. right? But then remember, this dot operator has a higher priority. So if you don't fit correctly, it will try to run this first because that's the dot operator. So we need to put this inside the parentheses. Actually, you don't need to, I think. And then we need to make sure this will cast first, then the sniff is called. So let's put the parentheses around that. Okay, I don't think I need the second parenthesis because it has a higher precedence. This dot has a higher precedence. So this will run first and then cast it into dog, okay? Cast it into dog and then call the sniff method. So that's how you run. And now this is polymorphism, right? This is dynamic binding polymorphism. Of course, inheritance. But polymorphism, because animals is an animal reference type. But when it runs, it actually goes to the dog class to run that method. So it changes forms when it runs. It changes from an animal to a dog, to a cat, etc. That's polymorphism. I'm going to run. And you can see this is the output. This output is simply the this part you already know. So this is the part where I added the sniff and the stare and hide method. And you can look at it, right? This is the cat and this is the dog. So that's the method call. I think that's it, everybody. Yeah, okay. That's it.